for NASA's Mission Directorate. Thomas, thanks for being here. It's starting to clear up. We can actually see the pad now. Tell us, how does Landsat tie into the entire Science Directorate portfolio?
Marie, what an amazing day. I'm just so excited.
Good morning, good evening, wherever you may be, and welcome to the My Live launch coverage of the Landsat 9 launch on top of the Atlas 5 rocket for the ULA. This particular launch is performed by using the Atlas 5 rocket. The Atlas 5 will operate by the United Launch Alliance, and it's a workhorse of that ULA family. The Atlas 5 currently flying in a 401 configuration, which means it's have 4-meter diameter fairing and have a zero booster. So there is no booster on this particular flight. Solid booster which support the launch, and single upper stage and single engine upper stage, which means there is only one RL10 engine, not two. This particular mission main purpose is to launch a Landsat 9 into the 708 kilometer circular orbit into in a sun synchronous orbit, and then subsequently through two-burn they will reduce the size orbit of the altitude, and then they will deploy their CubeSats and then perform another burn to deorbit itself into the Indian Ocean or Pacific Ocean, wherever it's located. So what's the Landsat? Landsat is NASA's, I would say, NASA's super best missions ever. Landsat A will cover the launch, will monitor the Earth, providing the tons of information which will be utilized for the fruitful purpose. So Landsat is actually a very unique capability which NASA have. Let's hear from
the USGS. Landsat holds the title for the longest continuous space-based record of Earth in existence. That's 50 years of scenes like these, helping scientists and researchers understand how our planet is changing over time.
So we just saw a video there about Landsat having archived 9 million images and counting. We're adding 700 every day to that. Until the earlier 2000s, this data was not
launch coverage will end with the second stage engine
free. It's
completion of the second stage second stage first one completion, and because there is a huge gap between the spacecraft separation, so I will be not going to attempt to cover the establishment video. So basically, Atlas 5 rocket is two-stage launch vehicle. The first stage is powered by the RP1 and liquid oxygen, and it's a single RD-180 engine with two nozzles. So it's not a two engine, it's a single engine but have two nozzles. So many people are confused that there is a two nozzles, so there is a two engine. No, it's not a two engine. It's a single engine but with a two nozzles. The second stage will be powered by the RL10, the world's most reliable launch rocket engine ever, I would say. Powered by the RL10 upper stage. It's a 4-meter fairing compared to the 5-meter, which is very big and long. This is very small compared to that, because the spacecraft is small, so it's stored into the small fairing. Atlas 5 is very versatile launch vehicle. It can fly with the booster, 1 booster, 2 booster, 3 booster, 4 booster, and 5 booster. It's very unique that it's a single, it fly with a single booster also.
Thank you so much for joining
very
us. Enjoy
versatile
the launch.
and very fancy launch vehicle, I would say.
Daryl and Mick to take us through these final minutes before liftoff. Guys?
All right, thank you, Marie, and welcome back into the Mission Directors Center. We've been listening to the launch team and just got some great news from NASA Launch Manager Tim Dunn. who declared that Landsat 9 is now an internal power. That means things are looking really good.
Yeah, Tim Dunn
So Landsat 9 internal power means currently
notified
till the launch this time the vehicle get the Landsat 9 get electric supply from the ground system, but now it's a cut between the
excited to hear about that. Next up, we will hear from United
outer
Alliance.
so it's now on its
Dr. Scott
own
Warner.
internal
He
power,
will
which is the
perform at
batteries.
L-7, the ULA teams poll, where we will hear the team give their go, ready to enter terminal count. And as we mentioned earlier, Launch Director Tom Heater will give that final proceed to launch.
And of course, a dedication going up on the rocket with his name on it. His second
If anything goes on with the launch, I
We'll
will
be
not going
listening
to
for
cover
that
that
poll,
further.
which is coming in at L-7 minutes. If you look across the bottom of the screen, you can see we're at weather briefing. Coming up is polling, and we'll hit that at L-7 as we count down. 60 more seconds until that moment. As we look out at the rocket, we see that there's
Here you can see the beautiful
that doesn't
Atlas
affect
rocket.
the chance for
The
launch.
first stage
But
is
Nick, it's
vending
nice
due
to
to
see
the
that there's a
liquid
little more
oxygen.
visibility, 4 miles
Very cool
visibility,
shot
which is
coming from
exactly
this
the distance
Atlas
between
rocket.
this rocket and our host.
So this is not Cape Canaveral launch site, it's a
Yeah, I feel
Vandenberg
a
Air
lot
Force
better
Base,
seeing some of that
which
fog
is
clear off.
on another side of the country. It's a long space launch complex 3 East,
Like you said, the
and
weather
it's
is
good.
really cooperating.
Particularly
This morning
set to
as this
deliver
fog
the
clears
Atlas
in and
rocket
moves
into
out.
the orbit.
Weather still remains go, and the United Space Force has assured us that we have a green all the way through.
We are going for
And once they go green,
countdown.
once this thing launches, it will be the
If I am not
2,000th launch from Vandenberg Space Force Base, as well as the 300th Atlas. Let's listen in now as they conduct that poll.
L-7 minutes. Status check to proceed with terminal count. Atlas system. Propulsion. Go. Hydraulics. Go. Pneumatics. Go. LO2. Go. Water. Go. Centaur systems. Propulsion. Go. Pneumatics. Go. LO2. Go. LH2. Go. Gas. Go. Electrical systems. Airborne. Go. Ground. Go. Facility. Go. RFFTS. Go. Flight control. Go. GCQ. Go. Operation support. Go. Com. Go. Umbilicals. Go. ECS. Go. Red line monitor. Go. Quality. Go. Op safety manager. Go. ULA safety officer. Go. Vehicle system engineer. Go. Non-light chief. Go. Range coordinator. Clear to proceed. Launch director. You have permission to launch.
So we have go from the this department, and we are going to launch on the target time.
1812 Zulu, that's UTC time, and we are go. And I got to tell you, it was nice to hear Tom Heater III give that go right there at the end.
Absolutely. I got goosebumps here, Daryl. Every time we get to this point in a launch, it is great to hear the team give their goes. And this is special for me, too, to dedicate this to Mr. Tom Heater II and hear Tom Heater give that proceed to launch. That is so... I can't even explain how I'm feeling right now. I'm so excited for Landsat 9 this morning. Looking forward to this launch.
His family and friends also here present to watch this with all of us. We are now counting down to the T-4 hold, where we're going to get those clocks synced up with the T clock and the L clock. This has kind of been a windy road to get to this point, though, Mick. This launch originally scheduled for September 16th. It moved to the 23rd. There were some issues with liquid nitrogen getting into the pad because of a COVID-19 induced issue with liquid oxygen back in Florida. So it created a shortage here. Moved past that. Also had a little issue with the spacecraft getting it out
Yeah,
because of the wind.
distance for 5
But
meters
Launch
from the
Services
launch.
program stuck with it, stayed the course, and got us to the launch day today.
Yeah, you know, I'm very proud of the team. NASA's Launch Services Program, our commercial partner, United Launch Alliance, the United States Space Force, they worked hard to get through this. It has been a windy road to get here, but you know, the team's dedicated. This is just part of the rocket business, and these guys have maintained their processes, followed through their procedures, and worked diligently to get us here today, Daryl. So I can't say enough about the teams that have continued to bring us here for Landsat's launch this morning.
As we approach the T-4 minutes, what do we expect to hear?
So we're going to hear them
On
pick
my
up the
mark,
count.
The time will be T-minus 4 minutes and counting. 3, 2, 1, mark.
So we just heard the L clock and the T clock will sync up. We are now entering terminal count.
So we are
At T-minus 3, we will
from
hear the
ground.
team secure topping and verify that everything's at flight levels. Around 2 minutes and 50 seconds, we will hear that the flight termination system will go to internal power, making sure that all the safety protocols are on the rocket as we launch this morning. And around 2 minutes, we'll hear that the Atlas and Centaur vehicle go internal on battery power, which is a clear signal that we will be launching on time this morning. And then at 1 minute, we will hear the United States Space Force give us a range go or green thumbs up, and we will then proceed into our T0 mark for Landsat 9 this morning.
As you can see there, the rocket against dreary backdrop
As
with
still
a
3
marine layer,
minutes from the
a
launch,
little
at
bit of
any
fog.
point
It's
team can hold the
93%
countdown.
humidity here along
Will
the
be
central
any
coast
issue
of
for her?
California. It's
Or
about
engine aboard
a little
itself
less than
during the
60
fire
degrees
phase
for
of the
temperature
firing,
that's outside.
so that
None of that is a
if
factor.
anything goes
Over the
not,
past few days, we've also
if
seen
anything
some
not go wrong,
smoke from a nearby
so
wildfire.
if anything goes
in
wrong,
Sequoia National
then
Forest.
they will stop
There you're
this
looking right
particular
down the side
procedure
of
and
the
secure the
booster,
vehicle
the
and
Atlas V
payload.
booster, and seeing that condensation coming off that super chilled skin of the rocket.
Yeah, I love that shot, that rocket cam shot. That'll be a great shot as we lift off this morning. And as you said, seeing that super chilled tank as it filled with liquid oxygen and liquid hydrogen on the Centaur tanks this morning, we're just excited about this. And we just heard from the team that they're going to flight levels on the tanks, and so that's a good sign that we are getting ready to close those vent valves and move into what we call step 3 for flight pressures.
Once that rocket lights, that orange fire will certainly change the light and change the mood of many of the folks who are watching this. Certainly on TV, you're going to see all of that. We've got all the cameras focused in, all the angles on this rocket. You can see on the progress bar, we are go for launch. Our next
We are 2 minutes
point
from
is
the launch
liftoff.
now.
Vehicle internal.
So we just heard the call, Daryl, for
155.
vehicle internal. That's a good sign. We're
So
going to
we
hear
will
the
check
last
and
poll
reduce
to
internal
verify
phase,
everything
where
is
the
good.
rocket's own batteries will take over the control of the rocket.
There's where they're securing and shutting off the vent valves, and they're securing the
140.
vehicle.
137.
FTS armed.
Flight termination system is armed. We are getting closer and closer to that T0 mark, Daryl.
And there's a big moment at T-minus 45 seconds. What do we hear there?
We're going to hear the launch conductor, Scott Barney,
120.
verify from the last minute that everybody's ready to go, and we get a green to go for launch.
It's been a lot of work to get to this point, a lot of
110.
preparation. Let's listen in.
There we just heard vent valves locked, and as you saw it there, you pointed out earlier that steaming off the vehicle has now stopped. The vent
1
valves are
minute.
locked.
Rock, report range status.
The range is green.
That is a great sign to hear range is green, Daryl, that we are good to go. Coming up on that poll from launch conductor Scott Barney.
40.
Stable at step 3.
And just 20 seconds away from the launch.
25.
Status check. Go Atlas. Go Centaur. Go Landsat 9.
And there it is, the word to launch Landsat 9.
T-minus 10.
9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition, ignition.
And we are
And
liftoff.
liftoff. Liftoff of an Atlas V rocket and Landsat 9, continuing the legacy of an irreplaceable 50-year record on our ever-changing planet.
Control system response looks good. RD-180 engine operating parameters continue to look good. Vehicle has begun the pitch over maneuver. Body rates look good.
That pitch over maneuver heading it to the south towards Southern California and down to Mexico.
Now passing 40 seconds into flight. Engine operating parameters continue to look good. Pump speeds and injector pressures all within expected ranges.
There's a shot from our tracker cam above
It's
Marine.
infrared images
Now
coming from
55
the ground
seconds into
visual.
flight. Vehicle is now completing the
Camera.
pitch over maneuver. Body rate responses continue to look good. 3 minutes remaining in the boost phase of flight. Pump speeds and injector pressures on the RD-180 continue to look good.
It's onboard camera now.
Body rates continuing to look good. And at 1 minute 20 seconds into flight, Atlas is now supersonic, vehicle passing Mach 1.
Critical moment for the
And
rocket.
vehicle is now passing max Q, maximum dynamic pressure.
So vehicle entered into the max Q, which means that is the most toughest phase of the flight, because that point will push actually very hard on rocket.
Engine's now
The
throttling
rocket
down slightly as
engine
expected. Engine response looks good.
must need to be very strong
Throttle down
to
from the 19-story
support
tall
this
vehicle.
particular
1 minute 50 seconds into flight.
fighting
Vehicle is
that
now
atmosphere.
10.7 correction, 13 miles in altitude, 7.9 miles downrange distance, traveling at 1,500 miles per hour. Now just under 2 minutes remaining in the boost phase of flight.
You can see beautiful flame coming out from the RD-180 engine.
At 2 minutes 18 seconds, the Atlas V vehicle now weighs just 1/2 of its liftoff weight. And vehicle's gone to closed loop guidance. Body rates indicating a slight adjustment can be expected for this phase of flight.
There's a beautiful shot right there, looking back towards the planet. And see the plume from the RD-180.
And the reaction control system on the Centaur is now pressurizing to flight levels. System pressure response looks good.
So the reaction
2
control
minutes,
system on
50 seconds
Centaur,
into flight.
they're prepping it.
Operating parameters continue to look good throughout boost phase. Body rates remain stable.
Coming up in 60 seconds, the booster engines will cut off.
Flight. Approximately 1
So we
minute
are 1
remaining
minute
now
away
until
from
booster
booster
engine
engine
cutoff.
cutoff.
Our tracker shot getting a great
And now 3 minutes 15 seconds into flight. Atlas is 48 miles in altitude, 70 miles downrange distance, traveling at 5,600 miles per hour.
shot as it goes out over the southern Pacific.
Pump speeds and injector pressures on RD-180 continue to look good throughout boost phase. And the Atlas V is now throttling to maintain a constant 5G acceleration limit. Engine response looks good.
Speed currently 7,700 miles per hour.
Cars begun boost phase chill down. Now throttling to maintain a constant 4.6G acceleration limit in preparation for BECO.
This is where the booster engine cuts off and then separates.
And we have BECO booster engine cutoff standing by for stage set. And we have good indication of Atlas Centaur separation. We have pre-start on the RL-10, standing by for ignition.
And there you see the separation.
We have ignition and full thrust on the RL-10. Chamber pressure looks good. Body rates look good.
Beautiful shot of the booster falling away as you're looking
And we have
down.
good indication of payload fairing jettison.
And you should see the
This
payload
first burn
fairs.
today.
Sometimes they come around the side.
12 minutes, 11 seconds.
There you see
And we
them.
have payload fairing addition also.
Good in the early part of this first burn. Now passing 4 minutes, 47 seconds into flight.
So we're in a good point, Mick. Flight is looking good. We're going to monitor the situation here. But what a beautiful launch. What a beautiful flight so far.
5 minutes.
But there's still a lot of work to do.
Yeah, absolutely. A lot of work to go on, but beautiful shot there of the RL-10 engine in space, sending Landsat 9 onto its orbit. A great launch this morning. So excited for this.
We're getting some of that orbital sunrise on the engine bell there, and that's just a neat look as you look back at our planet. All right, Marie, we'll keep track of things in here, but for the meantime, we'll send it back out to you on the hill.
All right, thanks, guys. We did get lucky enough for that marine layer to clear so we could see lift off from here at the gravel pit. Earlier, I had the opportunity to speak with NASA Administrator Bill Nelson about today's launch. Take a listen.
NASA Administrator Bill Nelson, thank you so much for joining us. You have described climate change as an all-hands-on-deck global challenge that requires action now. Tell us, how does the Landsat program help leaders take action now to address climate change?
We best get on the business of doing it right now. And what Landsat does, it is the longest continuous global satellite record of the Earth's surface. And these satellites have documented Earth's changing landscape. It helps farmers, scientists, decision makers with the tools they need to make tough decisions about our future. It's exploration on other planets, helping to answer the age-old questions. How did we get there? Are we alone? It's the inspiration of the next generation. That is what this science budget is all about.
And besides Landsat, in what other ways is NASA making it a priority to understand and respond to climate change?
Well, we are doubling our efforts to lead when it comes to climate science. Earlier this summer, we announced a new Earth Systems Observatory. It's going to be 5 great observatories that will look at the land, the oceans, the ice, and the atmosphere, and combine a 3D composite of what is happening very precisely to our atmosphere. That, combined with all of our other existing assets, such as the Landsats, it's going to develop the ability for us to really measure what is happening. And also, we're continuing to develop resources for sustainable aviation. That is less pollution in the air from aircraft, and it will keep industry in U.S. competitive and drive fuel efficiency that helps the environment.
Administrator Bill Nelson, thank you so much for your time.
Thanks a lot. Have a great day.
All right, there is the live view on your screen now of Landsat on its way into orbit. Turning now to one of the many practical applications of Landsat, the U.S. Department of Agriculture uses it to track annual yield of every crop grown in the United States. Disaster managers can see impacts from floods and other natural disasters. Resource managers can use the data to direct crop rotation and monitor water use. Take a look.
America has always been a fertile land. Grasslands and forests and farms, from sea to shining sea. The U.S. Department of Agriculture tracks how many acres and the annual yield for every crop produced. From the big ones like corn, wheat, soy, to regional crops like cotton, rice, citrus. They track every year using data from Landsat satellites and others, combined with data from surveys on the ground. Landsat satellites see detail at the human scale, about the size of a baseball diamond, and can image individual farm fields. The program started in 1997 with North Dakota as an experiment. Other states became interested, and the program grew. In 2008, Landsat data became free to use, and the USDA could afford to map 48 states. During the growing season, the data helps estimate crop yields, which helps farmers and traders set prices for the harvest. Thanks to Landsat's detailed view, the USDA tabulates stats crop by crop, county by county, and state by state. At the end of each year, the data set is released to the public, and it is a beautiful sight. The patchwork of corn in yellow and soybeans in green in the Midwest. The diversity of crops in California's Central Valley. The clusters of citrus in Florida and California and Texas. We can see changes in farming through the years. The easiest to see is crop rotation in the Midwest, cycling between corn and soybeans. In northern North Dakota, there is a shift from barley and wheat to soybeans and canola. And we see an increase in cotton fields, shown in red, in Texas and Oklahoma. Thanks to the free and open access to Landsat data, the U.S. Department of Agriculture is providing our farmers with accurate data and helping maintain our nation's food supply.
All right, we want to bring in a special guest now from Northrop Grumman, the company that actually built the Landsat 9 satellite. Frank DeMoro, you are the Vice President of Tactical Space Systems for Northrop Grumman. And I understand this is your first launch out here at Vandenberg. How was it?
It was really special to see that rocket lift off.
Yeah, well, I tell you, we got a little lucky. It's also my first one, so we shared that together. But the last couple of days, the marine layer has been so thick, it's been very hit or miss, our view from here to the launch pad 4 miles away. So we lucked out. I'm glad you got to see it lift.
Yeah, it was a special time. Special time.
So this is Landsat 9 is the 4th satellite that Northrop Grumman has built for NASA. Tell us about the process. What goes into building a Landsat satellite and integrating it with the instruments?
Yeah, well, of course, the satellite that we build, the platform part of it, is really there to carry these special instruments to do the work that Landsat 9 is going to do. And so we have a dedicated team of engineers in Gilbert, Arizona.
Have to go right for a rocket launch to happen. And certainly the workers that you described in Gilbert, Arizona are a big part of that. All of the meticulous work I'm sure they had to do to get to this point. Can you talk a little bit about that team, what it's been like working through the COVID pandemic and any impact that's had at all?
Well, it's a really special team, and they're so dedicated to this mission. The fact that this is our 4th Landsat mission, partnering with NASA all these years in this type of mission is really special. And the team understands that. And as they've worked through the past year and a half, they've just continued to work through the COVID period, being dedicated to this mission, knowing what it really means to NASA, what it really means to the nation to get this data down to the ground. So they've persevered, they've worked really hard, and I'm really so proud of them. Mainly, that's the main thing I'm most excited for today, is what the team gets to see.
Well, congratulations to you and the Northrop Grumman team.
Well, thank you very much. Appreciate it.
You're welcome. Thanks for being here. All right, we are now at launch plus 14 minutes, 37 seconds and counting. We expect Landsat 9 to reach orbit, its intended orbit, in just a few minutes, and here's some things to know about that. It will circle the Earth at an altitude of 438 miles. It will travel at 16,760 miles per hour, or 4.6 miles per second. Each orbit around the Earth will take 99 minutes, so Landsat 9 will complete 14 orbits per day. Landsat 9 will take more than 700 pictures of Earth every day. All right, and as I mentioned, we are approaching that orbit milestone, so let's get over to Daryl and Mick to take us through the next few minutes. Guys?
That's right, Marie. We are just seconds away from main engine cutoff. Centaur has been burning now for several minutes. It's really close. When this happens, we're going to be in an orbit that's a little bit higher. You just heard we're just about a minute out.
Yeah, so what's happening is we have this first burn, and we're trying to get a slightly lofted orbit this morning into that near-polar sun-synchronous orbit, Daryl, so that we can get Landsat 9 up there. What will happen is main engine cutoff will occur, and then we will coast for several minutes to get Landsat 9 into the orbit it needs to be, and then we will get spacecraft separation at L plus 1 hour and 20 minutes.
Hard to believe we're just a few seconds away from main engine cutoff, but hard to believe this spacecraft in this rocket have gone almost completely around the planet. Currently coming up through eastern Africa, over Turkey. We're just seconds away. Let's listen in to the call from main engine cutoff.
And we have MECO, main engine cutoff. Body rates look good. Vehicle is now recovering from the shutdown transients.
So this is the end of
And there you go, Daryl. We heard from United Launch Alliance commentator
You can
Patrick
watch on
Moore,
the
who's done a
website.
fantastic
Thank you so
job
much
since
for joining
liftoff
with me.
of filling us
So
in
good
on
night.
all the activities that have been going on.
And we'll
we
meet you
just
soon
got
again.
confirmation of main engine cutoff. So Landsat 9 and the Centaur will coast for a little bit, and then we're about an hour and 3 minutes from Landsat 9 separation.
Yeah, it'll coast for a lot of bit.